when we talk about fish signal interpretation, really there are only 5 different kinds of signals to interpret, and all 5 of them are up on your screen. The first 3 are nothing more than a variation on a theme, whether we're talking about single color or dual color or triple color. There is one probe set that's triple, or multicolor, which is generally considered 4 or more. They're all variations of counting spots, and we crudely in the fish laboratories refer to this as spot counting. The fusions and the break-aparts are different kinds of probe sets. They're only seen and utilized in the leukemia and lymphoma or the hematologic fish testing, and we'll talk about those specifically in the 3rd module. Before we start, I wanted to give you a picture of both an interphase nuclei, which we see in the lower left-hand corner of your picture, and a metaphase spread. The interphase nuclei is what you'll be doing all of your fish analysis off of. It's what we do all of our fish analysis off of. But I put this slide in there so that you can get a sense that when we identify signals and we relate those signals to genes, that they are indeed what we and what the manufacturers say they are. Despite the fact that these come from the manufacturer with a certificate of analysis or a certificate of qualification, we still, as part of our validation process, reverse map these probes onto metaphase spreads. This is a metaphase DAPI banding. We know that this is a number 11 chromosome. This particular gene resides in the middle of the long arm or the Q arm of chromosome 11. We add to it a telomere control probe, which is the very terminal end of the long arm or Q arm of chromosome 11. And by looking at the positioning, we can tell that the Q or control probe went exactly where it was supposed to go, and the target probe, in this case the ATM gene, which happens to be one of 6 genes that are targeted in our CLL panel, goes exactly where it's supposed to go, and that is the middle of the Q arm of chromosome 11. Again, we won't have the luxury of looking at chromosomes and metaphases and making these interpretations based on this, but we'll be looking at this. And so the idea or the purpose behind this slide is that you can rest assured that we have seen these signals. They hybridize right to the specific band or subband that they're supposed to. And when we look at an interphase nuclei like this and say 2 red, 2 green, normal, it's because we know where these 2 red and where these 2 green hybridized to a control metaphase as part of our validation process. If everybody can turn to page 4 of their Tech-Only Fish Manual, it should identify Fish Probe List 2.1. Look about halfway down on the left-hand side and you'll see MDS fish probes or fish analysis. In your first column, and what I'd like to do is, using this picture that's on your screen as an example, take you through how we utilize this manual and how it will serve as a resource to you. Chromosomes 5, 7, 8, and 20. Those are the chromosomes that are involved in fish analysis for MDS. Although we're not going to talk about the hematologic fish panels, it illustrates the point. If you look at the next column, you can see that that's the location or the loci of the gene. And it is either in the P arm or it's in the Q arm, or when we get to Eurovision, you'll see that it's in the centromere area. The next column is the actual gene itself. You may or may not need or want this information, but it's there for you in terms of what gene or at what location this probe hybridizes to. The next column is the color. And if you look at chromosome 20, which is up on your screen, you can see that it localizes to 20q12. That's region, region 1, band 2. You can see what the gene is, and you can see it's red. And then if you keep going across, you'll see that this particular assay is a spot count. The normal pattern is 2R or 2 red, and that's exactly what you see here on the screen.